Good morning, ladies and gentlemen. Welcome to our today's webinar, Scanning of Profile Cross-Sections. There will be finally two parts because the profile cross-section scanning is something you can do with and without the Cobra RF software. It's an independent unit that can be used, for example, based on teached or DXF cross-sections, and that can be used in a second stage also directly with a direct connection to the Cobra software. Today we will show you what the possibilities are, what the background is, and we will also show you or give a short presentation of the software itself, how it can be used, as it is more or less state-of-the-art software architecture that we can be using here. So a short agenda, what will be the content of this webinar. Of course, there is various principles how sections could be measured by means of laser or, for example, by sensor rings, various sensor systems, mostly driven with a camera. We are having a short look on the product portfolio that DataM is providing. Then we have a demo of a Cobra Profile Scan desktop with a software presentation, like definition of the measuring tasks, how the respective results can be exported, and what interfaces to CAD systems are available. As you know, there are various problems, various sections that need to be measured. We have, in terms of information we would like to have, we are interested very often in spring back rates of the profile. End flare might be a big issue. So this means after cutoff, the ends of the profile are opening up. Of course, the references are not correct in a section. There's misaligned geometry. So the reason might be this adjustment, or misalignment of the roll-forming machines. There might be the reason that the roll-forming tools are worn, so they do not operate in the way they are supposed to. There could be a changing material quality. Everybody knows what can happen if you use the same material from different suppliers. First it was working, you're just changing the material with the same specifications, and suddenly things do not work anymore. So to make sure that the quality can be checked, these cross-sections need to be measured in a simple and easy way. And this is a possibility that the profile scanning here would allow. You see here various sections, cross-sections from various industries. There is wire rolling, which is one possibility, where you see a few samples on the lower right side here. It could be cross-sections like tubes, but tubes do not necessarily have to be round, and of course open sections or welded sections. We do have various possibilities how measurement could be done. So the easiest one and the most well-known one is to do that manual with a caliper, which is quite inexpensive, but also has limited possibilities to measure specific dimensions, and is to a certain extent what the demands of today are, a little bit inaccurate. Also, it is very, very complicated to measure various reference lines. For example, if I need a 90-degree angle, okay, 90 degree might be still okay as well as measurement toolings for that. But if I want to measure any angle, it gets already very complex. There is the possibility to use profile gauges, which is more or less a negative caliper. But it is also quite inaccurate because you never can be sure that the complete contour will match, or it's difficult to find the correct position so that all dimensions are measured more or less in the correct way. One possibility to scan a profile section is at the moment supplied by the corporate roll scan already. As you can see here, it will give you a quite accurate shape and measurement result of the profile section, but it always requires quite intensive preparation of the part. So this means I have to cut the part. It shouldn't be longer than 5 centimeters. You have to make it stable for somehow, so put it into a kind of fixture. And so this leads to a certain effect that you cannot measure specific information like end flare. Of course, there's the possibility to use a coordinate measuring machine or machines that take one photo, but these machines are usually very expensive, and depending on the measurement possibilities, also you need to teach in the contour first, or the measuring program is required, or it's difficult to measure radii and all these things. Therefore, the target was to find a possibility to get a cheap device that is in the situation to measure, a section very quick, very easy, and that supplies the possibility with a direct CAD link. So by scanning by means of laser means the light section principle. So you have a problem like with a few sensors, for example, inline measurement. These sensors usually have a laser and a camera connected with a sensor matrix, taking some pictures, and with a specific measurement method, the contour of the laser beam shown here can be extracted. And of course, that sensor principle now gives you a lot of possibilities. For example, you have a sensor and you have a field of view. So of course, the camera inside the sensor needs to be focused into a certain area. And then you have, in the field of view, you have the profile that should be measured. To measure the profile now in one go, here a simple section, you need at least 2 sensors. If the profile shape gets more complex, you need at least 3, maybe 4 sensors, depending on the problem you would like to measure. And as you can imagine, the more sensors you have, the more expensive the whole solution will be, and the more complex it will be to make a correct setup, because everything, all sensors, need to be referenced to each other in the correct way. So there is setups like more or less in a serial approach, or in a kind of ring, sensor rings, as that they can be applied. Cost-wise, it's probably per sensor for the complete solution, you can calculate roughly 10,000 euro. So now, to have a simple device that allows measuring in a simple way without doing a lot of referencing, and to supply a cheap solution, the best is to use only one sensor. But how can I measure with one sensor a complete section? Very simple. You just let the part rotate. And now this configuration has a lot of advantages. First of all, it is only one sensor, so it's not so expensive. And you have access to all the parts inside the section that you can measure with light, or with a laser light. So these are the typical features here. Low cost, as only one sensor is necessary. You're having a complete scan that is taking a complete circle of 360 degrees. It supplies a very good accuracy and can be operated offline. So it is portable. You need it in one line, okay, not a problem, you use it there. You want to go to a different hall, you take the device in a little suitcase and use it in the next hall, for example. You can also inspect areas with an undercut, as this picture is showing you. If you have 4 fixed sensors, you will always have a red area in the left above picture that cannot be taken care of. If you rotate the section with only one sensor, the red areas are getting very, very small, but you cannot really measure directly. And as you can imagine, by the possibility of taking 360-degree scans, there is an unlimited number of views that are possible, or nearly unlimited number. Before we come to an online software presentation of the Profile Scan Desktop, a short overview, only one page, don't be afraid, on what DataM is doing. You know, the focus of our company is on roll forming, in a newer version, also not as big, but a small focus also on wire rolling. Of course, you know, the tool design and simulation software that we supplying here for roll forming and for wire rolling. There are special applications also for sheet metal bending. Products that today are very often integrated in CAD systems. You might remember that the sheet metal product inside Inventor is coming from DataM. The inspection devices we are offering is the Cobra roll scanner. Everybody, or nearly everybody, knows that device, that makes sure that the roll geometry coming from a roll supplier is okay. An ongoing quality control is possible, or also re-engineering is possible. New is the integrated roll lifecycle management, in which the roll scanner plays a quite important role, as you can expect a roll after and document a roll after it has been working for, let's say, 50,000 meters. You can check the effect of the work the roll has to do on the geometry of the roll. Of course, we are offering training and support for our software, for our customers. We are doing research and development services. We are also doing consulting services. So if somebody should have a problem with one product, we can try to help them out. The research and development activities are also including some improved devices for material testing. So the problem is that making a strain or strain gauge, you are more or less leveling the results if you're making a strain test, elongation test. So we added a bend tester to have the possibility to get better results for bending also. For quality control, this is now the last development with the Profile Scan Desktop. So this can be driven as desktop device. It can also be used as an inline measurement device. The sensors would be the same. You see here an inline setup, or it can also make sure to cross-check the life cycle of a tooling. For example, a profile you are making for many years will have somewhere roll wear and so on, and this will show some results on the profile that can be made visible this way. So therefore, all the points you have seen before, the benefits of this solution you have seen in the previous page, can be supplied with the Profile Scan Desktop, just supplying a single sensor. One thing that could be of interest, of course, it is very, very important to have a good referencing of the individual snapshots we are doing of the section during measurement process, and this specific method has been patented. We are going now to have an online presentation of the Profile Scan Desktop. To give you a short impression, we are running this video here, so you see the device on the desktop device. You just put the cross-section you would like to measure into the table, into the turntable. You have a little notebook on the side which is running with a Windows application. You load a specific contour you would like to compare it to. You just rotate the cross-section with the turntable by 360 degrees, and within 1 or 2 minutes you have a result. You have a result now in the computer. You can load a DXF file, you can compare it with the DXF file, you can reference it to various reference lines, and so on. So now we have a short presentation of the graphical user interface. This is an online presentation, what the possibilities of this software are. Ease of use was very important for us because it needs to be operated in any place, probably in the company. It has to be robust. It runs on a notebook PC or tablet PCs. There are interfaces to CAD systems and, of course, interfaces to our Cobra rule form software. So the next part 2, will be made by my colleague, Mr. Udo Lang. I now pass the micro for him to make the presentation, this online presentation.
So, hello, my name is Udo Lang. I'm the main developer of software of Cobra Profile Scan desktop, and I will show you the software directly on this computer. So I must change to desktop. So first of all, I must put the profile into my scanner. Everybody should open the video inside your NetViewer, please. So the profile must only put in the center of the scanner. Should be a vertical, so it's parallel to the rotating axis. And now I only start the software. And now I want to show you the software without having any information about this profile. Perhaps you have a profile which is new and you want to make a new project. We have here a project manager. We make a new project. I call it webinar. Okay. So then we only have to start measuring. Now you see one view of this profile, and you see also here the reference lines, and I will only rotate by 360 degrees. Now I've got a point cloud. Oh, I was a little bit too fast because here there's missing a line because of NetViewer. The computer is a little bit slower than normally. Now I have here also this line. So I want to measure some dimensions of this profile. And first of all, to get better results, we don't measure point to point. We measure lines to lines, or arcs to arcs, or line to arcs, or something like this, to get this we first of all must defining some contour elements. You only have to move over the contour and you get some regions. So if we have difference between line and arcs, and if it's near to a line but it's a little bit like an arc, he asked me, do you really want to make an arc or do you want to make a line? So here I want to have an arc and I use it, and we put here some region on it. Now we have defined the complete outer contour. I finish this, and now you see, I can remove this region now. You get these white lines and arcs, and from each arc we get the center point. Now it would be possible to define some measurements, but first of all I want also have not like it's in the scanner. I want to rotate it first. So I click on this line and everything is parallel now. And also when you want to measure a second time the same profile or upper part but with the same program, you need some reference line to say, okay, this line defines where's the position of a profile. So 2 of this must be a little bit bigger. So now we have this defined. We have some auxiliary elements, so this white things here are already the auxiliary elements, but we can, from existing auxiliary elements, we can make new auxiliary elements. For example, if you want to connect this arc with this arc, oh, sorry, this was not the arc, it was the region. So click on the arc. You get a line here. So you can get virtual elements which you don't see in the profile. For example, you can also get an intersection point of 2 lines. You can do it here also. You can project the point, for example, on a line. So this is the point where this line goes to this arc. So this is in the moment enough for me. Now we define some measurements. For example, I want to measure from here to here. Or I want to measure from here to here. We can also measure not only point to point, we can also measure from arc to arc. Or like here, from arc to a line. Okay, then we can also define some angles. For example, from here to here. Or also in the other direction. If you want to measure here to here, then you get here the result, and also from here to here, for example. So this looks a little bit chaotic. So you can move everything where you want to have. For example, like this. This you can move where you want. You can put it here or here, where you want. So now it looks better. You get already the results of this scan, you see, but everything is yellow. that means you have not defined any tolerances yet. So we can define for each measurement also tolerances. So this is the mean value, and for example we have a tolerance from plus minus 1. Oh, sorry, this software is, or this computer is German. Because of this, this is not a dot. Normally in English it should be a dot, but this computer is a German computer and this is automatically set to a comma. Okay, and we define perhaps this one should be something like this. So the tolerance can also be different to the sides. So he always displays the actual value, and you can change it to the value you want to have. So I think this is in the moment enough to define. So you see, yellow things, they have no definition of the tolerances. When it's green, it's inside the tolerance, like this one. And if it's blue, it's smaller than the tolerance. And if it's red, it's bigger than the tolerance. So also here you can see we can switch on everything which you want to have. If you say, oh, these auxiliary elements are not important, I need not the numbers of this, you can everything switch on and off how you want to have. So this is my project now. This I will store now. Okay. And now I can measure the same thing a second time. And you see, you get the new results of this second measurement. For example, you can also change here the height of a profile. So now I measure at the end of a profile, and you will see if I measure here. And you also see my starting point was different to the last one. Now it is on the other direction. Oh, sorry, I was too fast. Let's start again. Now we have a result, and what I also want to show, if you start in a different position, now it is rotated, you see, but you get also a result of this scan. So the starting point is not important. You can also save this point cloud as an PDS file. This is a format for our software with more information about the points, so you can reload such a point cloud and do some additional measurements on this old point cloud. You can also save this as a DXF file. And if I go to desktop, you see here is this file. And you can import die Verknüpfung. Ging nicht. Oh, no. Is it here? I must reload it a second time. Just a moment. Now let's try. Here's the possibility to show everything. I think this one. Okay. And now here you see you get the profile, and also white is this line and arcs we have defined before. So, and also you see that inside the profile we have also scanned the inner contour, but in this profile it's not important to measure because it's only the sheet thickness. So you can import in every CAD system which you want. So I also want to show you something else. So every measurement is stored in a file. Just a moment. Where's our webinar today? So we have here. You can import this text file into Excel or every other measure Tabellen calculation system. We get here the time and date of this measurement, and also every measurement. This we have defined 1 of this. The results of the different measurements, and also the factor how it lie inside the tolerance field, and this can be stored in a database. I can use it later. Okay.
So, gentlemen, you would have to use the chat window if you have any questions. So we are ready to answer anything now. So as you have seen, the way to measure things is very simple. It's fast. It provides the possibility to directly obtain those dimensions I'm interested in. It directly gives you the possibility to cross-check if a part is within tolerances. And as you have seen, if you created a template once, so this means you have created a template, you have added the dimensions, you know what the dimension should be, and you take a part from the next production, for example, and you would like to know if this is within tolerances, it will instantly give you the result to see if the new production is now within tolerances in all necessary situations. So this also means if you make a production after 1 year, you just recall the template, you measure the part, and you know within 2 minutes if what you have been doing on the machine is according to specification. So a short view again on the video. The part is fixed in the table, in the rotation table. The part template is being loaded if you have one on your PC. The part is being rotated by about 360 degrees in the profile scan desktop, and done. That's it. You have the possibility, as you might have seen during the presentation, to vary the height. So the table can be lifted up and can be set lower as it is. So you can measure a part, for example, in the center and close to the top and bottom edge of the section. So you have 3 different measurement results, and you can see how big the deviation between the individual situations or positions within the sections are within the profile are. Last but not least, on Thursday, 25th of April, there will be the next webinar on the Profile Scan desktop, with now showing the integration of this device with our Cobra RF software. And this is possibilities to directly link the Profile Scan desktop with the flower design in Cobra, which means you can, for example, cut out individual profiles from the machine between station 4 and 5, measure that and compare it directly with, for example, the design results. I just received a question, what kind of surfaces can we measure with this kind of device? Metal, plastic, wood, polished, matte, translucent, and so on and so on. Well, most of what you see here, most of those materials you have mentioned can be measured. Yeah, metal is okay, plastic is okay, wood is okay, matte is okay. Polished is in a way a little bit, sometimes a little bit difficult because you have high reflections, but we know there is a kind of spray available so that you can make the surface a little bit matte, and then it's again possible to measure the thing. Translucent? No, this is of course to measure glass is more or less not possible, but most of the materials that can be measured in an optical way with a laser can be measured with this device also. Especially highly polished can be measured if you use some kind of spray. You're welcome. One thing might be of interest for you. The scanner is now available in one size, so the maximum width of the profile you can scan is 80 millimeter.
Yes, if it's oval. If it's round or square, it's about 65.
So we have 65 in square or up to 80 in oval or flat oval sections, open, closed, whatever. Of course, we will also develop a device that is capable to measure bigger parts. So this is the next, would be the next step, but of course, the major range of cross sections that are in roll forming industry used today will be, a big portion can be covered by this device already. So, as I can see no more questions for the moment, thank you very much for attending this webinar.